Hey guys, good morning. Any questions or in general from homework or any trouble with anything in the homework? Okay, no questions. So we're starting 1.2 mathematical models. So the mathematical models or modeling in general is mathematical description in the form of the equations or the functions of real world problems. So the idea is this: when you can describe something using the mathematical model, it will let you analyze what will happen, what was happening, and in general to do some predictions in for the future. So let's start from linear models. So y is a linear function of x, then it has the form y equals f of x equals mx plus b. M is the slope, B is the y-intercept. So when it describes something, so at x equals 0, we have B value. M is in general slope of the linear function of the line. It's a steepness of the line, which shows how the rate of the function changes when x changes. Now, it tells you that for any two values, it's a constant rate of change. So, rate of change of the y value with respect to x will be constant. It's not different at different points. So, for any point, any 2 points you choose, it's always going to be constant. So, the graph is a line. Then, more general case will be polynomials. So, the polynomial p is a function of x. This is polynomial of one variable is given to you in this form. A0, A1 to AN are constant, which could be any real number. Those are the coefficients. And we consider as the degree of the polynomial as long AN is not equal to 0. So that would be the leading term in polynomial AN xn. And it will determine the power of the polynomial. So it's constant, linear, quadratic, cubic, or higher than that. N is in general non-negative integer. So it's 0, 1, 2, 3, and goes on. Domain for the polynomial functions is all real numbers. We do not have any restriction on this one. So polynomial of degree 1 is of the form px equals mx plus b. So it's linear function. Polynomial of degree 2 is px equals ax squared plus bx plus c. Is quadratic function whose graph will be parabola. Third degree will be ax cubed plus bx squared plus cx plus d, cubic function. So the first one, A, example of third degree polynomial. Second, B is degree of 4. Third one is 5. Now, if you notice, the graph of the polynomial is a smooth curve, no holes, no sharp corners or sharp angles, no cusps. It should be smooth curve, defined for all values of x. For even powers, both ends are going up or both ends are going down, depending on the sign of the coefficient. And for the odd ones, one end goes down, the other end goes up. Now power functions. A function of form f of x equals x to the a, where a is a constant, is called a power function. So if you notice, this one is a single term. If a is 0, 1, 2, 3, it becomes monomial, so polynomial with one term, but a could be any, can have any real value. So the several cases for a equals n is a positive integer. Then we have line, parabola, cubic function with one term, so just the leading term. Fourth degree will be similar to the parabola, y equals x squared. It's also parabolic, except close to zero. It's kind of, the shape will be a little bit different, closer to the x-axis, and then it increases faster than, let's say, x squared. X to the 5, x to the 7 will be similar graph to x cubed. So in general, the shape of the graph of f of x equals x to the n depends on whether n is even or odd. So if it's even, it's similar to y equals x squared. If it's odd, it's similar to y equals x cubed. Now, a equals 1 over n. N is a positive integer. For n equals 2, it's square root function, and now we have a restriction under the square root. We cannot have negative numbers, so the domain will be restricted from 0 to positive infinity. So graph of x equals, so y equals square root x is given here. So it's a upper half of the parabola, x equals y squared. For the even values of n, the graph of y equals n root of x is similar to that of y equals square root x. For n equals 3, if the index is odd number, then no restriction. We can have negative numbers under the radical, so the domain will be all real numbers. So y equals n root of x for n odd is similar to graph y equals cube root of x. If a is negative 1, the graph of the reciprocal function has this form. So f of x equals x to the negative 1 is 1 over x. So x cannot be 0. So 0 is excluded from the domain of the function. So we have vertical asymptote at x equals 0. So x equals 0 is a vertical asymptote. And when x approaches to infinity, 1 over infinity positive or negative infinity will approach to 0. So we have a horizontal asymptote also. Now, general rational function. Any function that can be put into form f equals p over q, where p and q are polynomials and q is not equal to 0, is called rational functions. So the restriction on rational function, denominator cannot be equal to 0. So q cannot be 0. Those points should be excluded from the domain of the function. Now, if the rational function in lowest terms, which means numerator and denominator, do not have common factor, then whatever makes denominator 0 for those values, x equals to those values, we will have vertical asymptotes. But if we have the same common factor in denominator and numerator, then you get a hole on a graph. So the point will be missing. So f of x given to you, this is example, not equal plus or minus 2. For those values we have vertical asymptotes, no horizontal asymptote, no oblique or slant asymptote. Oblique or slant asymptote we get when numerator is 1 degree more than the denominator. Then you can perform division, long division, and you can obtain oblique or slant asymptote. Now definition for algebraic functions. So a function f is called an algebraic function if it can be constructed using the algebraic operations such as addition, subtraction, multiplication, division, and taking roots, starting with polynomials. So any rational function is automatically an algebraic function. See example of algebraic functions. F of x, g of x, both of them are example of algebraic functions. Now trigonometric functions. So sine, cosine, tangent, cotangent, and then reciprocal of those functions. Actually, it's sine, cosine, tangent, and reciprocals, cosecant, secant, and cotangent functions. So the graph of the sine function, graph of the cosine functions are given here. You can see that they are defined on all real number line. So domain is all real number line, no restrictions on those functions. But the range is bounded. So the values of those two functions are between -1 and 1. It's a closed interval. They can attain all the values between -1 and 1. Now, both of them are periodic functions. That means after a certain period, in this case 2 pi, the function values repeats. So it means the graphs showing that the functions are not one-to-one. So when we're discussing inverse of those functions, mainly it will be in calculus 2. We put some restrictions to make it one-to-one. So for sine, we take negative pi over 2 to pi over 2. For cosine, we take 0 to pi. So all real numbers, restrictions. So sine x values are between -1 and 1, cosine x between -1 and 1. Now later, when we need to make some estimations, so this part will be used. So the fact that sine and cosine values are bounded, like between -1 and 1, so the largest value you can get 1, so you are going to use it later when you need to make some estimation for certain functions. So algebraically, when we need to estimate and make it simpler form. So sine x equals 0 for all values x equals n pi, n is an integer. Cosine x actually becomes 0, it's not here, so here. For pi over 2, 3 pi over 2, so plus or minus pi over 2, plus or minus 3 pi over 2. So you can write n times pi over 2 as long as n is odd numbers, odd integers. Now, periodicity. So sine x plus 2 pi is sine x, cosine x plus 2 pi is cosine x. Now, tangent is defined as a ratio of sine x and cosine x. So that's why we have a restriction already on tangent x. Cosine x occurs in denominator, so the zeros for cosine x are not allowed. So tangent x is defined for all values of x except x equals odd integer multiple of pi over 2. So plus or minus pi over 2, plus or minus 3 pi over 2, and so on. The range for tangent x is negative infinity to infinity. So we don't have a graph here, but graph of the tangent function over one period is like this. So at negative pi over 2, we have vertical asymptote. At pi over 2, we have vertical asymptote. Graph has this form. 0, we have 0. Pi over 4, we have 1. Negative pi over 4, we have negative 1. So the graph goes like this. Get closer to asymptotes. Now if you graph it to the right, we'll have this type of shape. to the left will be something like this, and you can continue. So tangent is also a periodic function. The period for tangent is pi. So tangent x plus pi is tangent x for all x in the domain of the function. Okay, any questions so far? So we're reviewing those from pre-calculus. Trigonometric functions cosecant, secant, and cotangent are reciprocals of the sine, cosine, and tangent functions. Now exponential functions and the inverse of exponential are logarithmic functions. If f of x equals a to the x, a is a positive constant and a is not equal to 1, x is any real number, then the function is called exponential function. Domain is all real numbers. So if the base a if a is greater than 1, then function is increasing function. Ranges from 0 to infinity. If the base is between 0 and 1, it's decreasing function. X-axis is the horizontal asymptote for the exponential function. 0, 1 is the y-intercept. We do not have x-intercept. So the graph gets closer to the x-axis, but never touches or crosses. So if on a graph you see that getting touches, it's wrong. So it should be away from the x-axis.
What was the horizontal asymptote, instructor?
What is the horizontal asymptote? X-axis.
Okay, thanks.
So if it goes infinity or negative infinity, graph gets closer to 0. So y equals 0 is the horizontal asymptote. Now, it's a one-to-one function, which means what? For any one value from the domain, there is exactly one value in the range. So there is a one-to-one correspondence. You can look at the graph, it passes the horizontal line test. So the inverse of the exponential function exists. The inverse of the exponential function is called logarithmic function. So logarithmic function is f of x that written in this form, log x with base a, where a is a positive constant other than 1. So this is inverse of exponential function. Now, domain is 0 to infinity, so we have a restriction. That's the range of the exponential function, and the range is all real numbers. So you have the graph of the logarithmic functions with the base 5, 10, 2, 3. So all bases are greater than 1. If the base is smaller than 1, let's say 1 over 2, 1 over 3, 2 over 5, or whatever, then the graph has this form. This way. So if it's greater than 1, it's increasing. If it's less than 1, it's decreasing function. This one has vertical asymptote. So in this case, it's x equals 0, so y-axis for all of them. So whatever makes the expression under the logarithm 0 will be your horizontal vertical asymptote. So if you have f of x equals log base 2 x minus 2, then this one is the original graph shifted 2 units to the right. So x minus 2 equals 0, x is 2. is a vertical asymptote. That's already shifted graph, that's why. Okay, any question regarding those functions?
The last part, x equals 2 vertical asymptote.
I just approximately do it. Yeah, the vertical asymptote, again, is y-axis. So the one that we have at x minus 2, yeah, it will be shifted. So if you have y,
Oh, it's going to be shifted to the right 2 units.
correct,
Okay.
yes.
Thank you.
Let's say 2x minus 2, right? Then when you graph this, 1, 2. So the vertical asymptote will be here. At 3, you will have x-intercept, so the graph will have the shape.
Okay, I understand. Thank you.
No problem.
Instructor, are we going to do chapter 2 today? No, we're chapter 1.3. Are we doing until 1.3?
1.2, not much to do. We'll do a few problems. And then, yeah, start 1.3.
Are we going to go further than that, or we're not sure?
No, if we go that fast, that puts in 2 weeks, we'll finish it.
All right, thanks.
So we don't want to do that, right? Now, this part is review. That's why we don't do much, because like starting from 1.4, 1.3 also will be review, but we have examples from there, more examples than from this session. But 1.4 will be already new for you. So I haven't even posted your new lecture notes for that one. So that one probably will start tomorrow. So 1.3 will start today, most probably finish tomorrow, and then go on from there. Okay, classify each function as a power function, root function, polynomial, stated degree, rational function, algebraic function, trigonometric function, exponential function, or logarithmic function. Now let's look at 2. Y equals pi to the x. What kind of function is that?
Exponential?
Say it again.
Exponential function?
Pi is a number, right? Yeah, it should be exponential function. Let's say 2 to the x, 3 to the x. So it's pi to the x. Pi is any real number, so it's exponential. Now B.
Power function?
It's a power function, correct? It could be, let's say, x squared, x to the 1 over 2. Pi is any real number, so it's a power function, correct? C.
Power function as well?
No, power function has only one term.
Exponential function?
No, exponential is a. It's to the power x.
Algebraic function?
All of them, or most of them are algebraic.
It's a polynomial function?
It's a polynomial. Sorry, the power went out. And, yeah, okay, don't worry now. So It's a polynomial. Yeah, if you distribute, right, it will be 2x squared minus x to the power 5. So so this is polynomial, and they ask you to determine the degree. So what's the degree of this polynomial?
Wouldn't it be 5?
Correct. Degree of 5. Now, D is trigonometric functions, right? E,
Rational function.
correct. F,
Algebraic function.
it's algebraic, yeah. You can write, let's say, involve radicals also, but you can write algebraic function and finish it, yeah. Now, this is definitely just a practice problem. It's not something that we'll see it on your exam. But let's do something else. Number 10, find the expressions for the quadratic functions whose graphs are shown. So, the first one, second one, let me graph it for you, and then we'll determine expressions. So f is given to you. This is 3. This is 4, 2. And then we have another one. Okay, so both of them are parabolas. So we need to find the expression for those two. So for parabola in general, we have two forms. F of x equals ax squared plus bx plus c. F of x equals a times x minus h squared plus k. The second one is standard form, first one is general form. Now, for the A case, which formula is convenient for us? First one or the second one? Which one can we use?
The first
Second.
Second, why? Why second is better choice? It's correct, but why?
Because
Because it moves over to the right 2. Or
Okay,
3.
HK is corresponding to what? Is the
Vertex.
vertex, right? For the first graph, vertex is given to you. It's 3, 0. See, for the parabola, see, for the line, we need only two distinct points, right? To draw uniquely defined line. For the parabola, you need 3 points, 3 distinct points, not collinear points. So you can draw the parabola passing through those 3 points. And in general, you have 3 unknowns in the equation, a, b, and c. But f of x equals a times x minus h squared plus k. hk is corresponding to the vertex. So for the first equation, for the first graph, it's convenient to do that one because hk, we have it already. hk is 3, 0. So that means f of x equals a times x minus 3 squared plus 0. So f of x equals a times x minus 3 squared. Now a is missing. To find a, we need to use what? Point 42, right? F at 4 equals 2. So 2 equals a times 4 minus 3 squared. So 2 equals a. Now we can write f of x equals 2 times x minus 3 squared. That will be the equation for the first graph.
You got the 2, if I remember correctly, from the 2 on the y-axis?
F, when x is 4, y should be 2, right?
Yes.
So f at 4 equals 2. So that means for function value, for y, we have 2, yeah. So if one of the point is the vertex, that means you need additional one more point to determine constant a. That's enough, 2 points, as long as one of them is the vertex. But if it's not a vertex, we need to have 3 distinct points. Now, for the second one, 3 distinct points are given to you. So that means unique parabola you can find. But which form of the equation do we need to use now? And kind of similar because both of them have 3 unknowns, AHK or ABC. But the first one is good, and why? We'll see right now. So the first one is f of x equals ax squared plus bx plus c. Now, f at 0 equals 1. When x is 0, you get 1. So if you plug 1 equals a times 0 plus b times 0 plus c, implies that c equals to 1. So c, we have it. So now f of x equals ax squared plus bx plus 1. Now we need to use the other 2 points to find the equations in terms of a and b, and then solve it for a and b. See, x is negative 2. I need to get f negative 2 should be 2. So 2 equals negative 2 squared is 4. 4a minus 2b plus 1. So I get 4a minus 2b equals 1. This is one equation. Now, f at 1 equals negative 2.5. So I have negative 2.5 equals 1 squared is 1 plus b plus 1. So now we have a plus b equals negative 3.5. So two equations, two unknowns. Let's write them here. So 4a minus 2b is 1. A plus b is negative 3.5. Now we can eliminate b, then we can eliminate a or substitute and find a. So if I multiply this by 2, I have 4a minus 2b is 1. A plus b is negative 7. Not a, 2a plus 2b. So 6a is negative 6. A is negative 1. So A plus B is negative 3.5. So B is negative 2.5. So f of x equals A is negative 1, negative x squared. B is negative 2.5. X, C is 1, plus 1 will be the equation. Okay, any question on this one? Have you done this type of problems in previous course?
Not much. Some.
In pre-calculus, when you study parabolas, most of the books have this type of problems. When you need to find the equation of the parabola, when the distinct points are given to you. But those two forms, you need to remember, either one will be used in the future for parabolas to identify them or to, let's say, find them. Now, for the first one, see the important point on a parabola is the vertex. Second one, standard form, allows you to identify right away. For the first form, to find the vertex, you use the formula. X coordinate of the vertex is negative b over 2a. Y coordinate of the vertex, you plug this number into function. So the vertex you find, that's the important point, and the rest, let's say graphing, or if you need to graph it, you can do by choosing some convenient points to the left, to the right from the x coordinate of the vertex. But if it's a second form, standard form, which you can obtain by completing square, then HK is the vertex. Okay, any questions? Now, 1.3. New functions from our old functions. So obtain new function by shifting, stretching, and reflecting their graphs and combining pairs of the functions. So when you're combining, you use basic operations, addition, subtraction, multiplication, division, and the fifth way to obtain the new function from the even functions is composition of the functions. But the first, let's look at transformations. So you have translations and you have general transformations. Translations means it's kind of rigid transformation, which means the shape and the size of the graph stays. It will be just shifted to the right, to the left, up or down. General transformation includes stretching and shrinking. So reflection also will be just a translation because your reflecting shape and the size will stay the same. Now, when you stretch and you shrink, the shape stays the same, but the size of the graph will be changed. Vertical and horizontal shifts. So C is positive number. So to obtain the graph of y equals f of x plus c, shift the graph of y equals f of x, c units upward. If it's f of x minus c, then we're shifting y equals f of x, a distance c units downward. If x is replaced by x minus c, shift the graph of f of x, a distance c units to the right. If it's x plus c, shift the graph of y equals f of x, a distance c units to the left. Now, let's consider stretching and reflections. If c is greater than 1, to obtain the graph of y equals c times f of x, stretch the graph of y equals f of x vertically by a factor of c. If it's 1 over c times f of x, shrink the graph of y equals f of x vertically by a factor of c. Now, if x is replaced by c times x, for the horizontal stretching and shrinking, it works with the reciprocal rule. See, shrink the graph of y equals f of x horizontally by a factor of c. C is greater than 1, remember. And if it's x over c, stretch the graph of y equals f of x horizontally by a factor of c. Now, y equals negative f of x is a reflection of the graph of y equals f of x about the x-axis. Y equals f of negative x is a reflection of the graph of y equals f of x about the y-axis. Let's go to the problem set. Okay, explain how each graph is obtained from the graph of y equals f of x. Number 2. A, y equals f of x plus 8.
We'll move the graph up by 8 units.
Up, correct. 8 units upward. If it's f of x plus 8,
8 units to the left.
8 units to the left, correct. To the left. 8 times f of x. Is it stretching, shrinking, vertical, or horizontal?
Stretching.
Stretch by a factor of 8 vertically, correct. So this is stretching. by a factor of 8 vertically. Now, if it's 8x instead of x, it's stretching or shrinking?
Shrinking?
Shrinking.
Shrinking, correct. Shrink horizontally by a factor of 8. Basically becomes 1/8 times, so it shrinks. And E, y equals negative f of x minus 1. Two operations.
It would move down 1 on the y-axis, and I think that's reflect on the x.
Correct, but you need to go right over there. Remember, when you have, let's say there is no special order of doing transformations, but vertical transformation do at the end. So first reflect in the, so x-axis, right? Y becomes negative y, and shift 1 unit downward. Okay, F. Eight F 1/8x.
Stretch and then shrink.
So stretch how?
8 stretch factor 8 vertically.
So stretch vertically by a factor of 8 and
Shrink horizontally.
no.
Oh.
Should be reciprocal. See, D was 8x, it was shrinking, right? Now
Mhm.
1/8 should be
Stretch.
stretching. Stretch horizontally by a factor of 8. So both of them are stretching. Okay, now let's do some graphing. Graph the function by hand and not by plotting points, but by starting with the graph of one of the standard functions and then apply the appropriate transformation. Okay, number 10. But let's, actually not number 10. Let's do something a little bit tricky. Okay, 14 and 15 will do. So 1.3, number 14. So y equals 2 square root x plus 1. Let's assume we're starting from f of x equals square root x. So first, let's make this y equals f of x plus 1, which means square root x plus 1. And second, y equals 2 times f of x plus 1, which is 2 times square root x plus 1. So when you change x by x plus 1, it will be shifting horizontally 1 unit to the left. When you multiply by 2, it will be stretching vertically by a factor of 2. So the original function, when you graph, we need to use a few points. So let's assume so the point we'll use is 3 point. You need to have it 0, 0, 1, 1, 4, 2. So this is the graph of, let's say, y equals square root x. Now, x plus 1 means 1 unit shifted to the left. So the points are becoming those. 0 moves to this point, negative 1. 1 moves to the left. 4 moves here. This would be your new graph. So y equals square root x plus 1. Now we can actually, let's say, use dotted lines for those, for both of them. So let me use dotted lines. So this is this one, and this is this one. So because we haven't finished it yet, and the last one, I need to stretch by a factor of 2. Now y equals 0 stays the same. Y equals 1 becomes 2. 2 becomes 4. This is 4. So this would be the final graph. So y equals 2 times square root x plus 1. Now you cannot plot the point, but at the end you can check. So you have negative 1, 0. You have x is 0, y is 2, x is 4, y is 4. Not 4, sorry, this is 3. This not this point. This point should be 4. And this point should be 4. So this is the graph, sorry. So it's good I checked the answers. So this is 3, 3, 4. Now let's check if we got it right or not. So 0, or negative 1, 0. So y equals 2 times square root negative 1 plus 1 equals 0. Correct. Then I have 0, 2. So y equals 2 times square root 0 plus 1 equals 2. Correct. Then I have 3, 4. So y equals 2 times square root 3 plus 1, which is 4. Correct.
The negative 1 and 0, that stayed the same, correct?
Negative 1, 0, yeah. It's same because 2 times 0 is 0, right?
Right.
2 times 1 is 2. And 2 times 2 is 4.
Mhm.
Now let's do 15. Any question on this one? No. So 15 is y equals x squared minus 4x plus 5. Now to use transformation translations, so the function is base function x squared. So you need to complete the square first. Let's see. Okay, so y equals x squared minus 4x plus half of 4 is 2 squared, subtract the same thing, plus 5. So I'm adding 2 squared and subtracting, which means I'm not changing anything, but this part I can complete the square. So y equals x minus 2 squared. Now negative 4 plus 5 becomes plus 1. Now, if f of x is x squared first, y equals f of x minus 2 becomes x minus 2 squared. Second, y equals f of x minus 2 plus 1, which is x minus 2 squared plus 1. So x replaced by x minus 2 means 2 units to the right, plus 1 means 1 units up. So 1, 2, 3, 5, 6. So x squared, you can use 0, 0, 1, 1, negative 1, 1. This is y equals x squared. Now shift 2 units to the right and shift 1 unit up, and you will be done. So 2 units to the right. Let's see. So 1, 2 goes here. 1, 2 goes here. 1, 2 goes here. So this would be your graph y equals x minus 2 squared. Then 1 unit up, So each of these points should go 1 unit up. This is here, this one is here, this one is here. That would be your final answer. This should be your parabola. Now you have, this is 1, 2, 1, 2. This one is 2, 1. And this one is 3, 2. Let's check. 1, 2. Y equals 1 minus 4 plus 5 equals 2, correct. 2, 1. So y equals 4 minus 8 plus 5 equals 1, correct. 3, 2. Y equals x is 3. So 3 squared is 9. Minus 3 times 4 is 12 plus 5 equals 2. Correct. So using the transformation, checking it's up to you. You can check, or if you are sure, you don't have to check. It means you start from the base function and then show the transformations until you get the last step. Okay, any question?
Yeah, I have a question.
Go
For in the beginning, where you wrote x squared minus 4x plus 2 squared minus 2 squared plus 5, where did you
Yeah.
get the 2 squared minus 2 squared?
So you need to complete the square. So when you have a squared plus 2ab, you need to add half of whatever you have here, coefficient, b squared. To write it, a plus b squared. So if you have a squared plus 10a, sorry. That means this a is a, right?
Yes. Yes.
To get b, I need to divide 10 by 2. So I need to add half of 10, which is 5 squared. This is b, 2b. If I divide by 2, I get b. I need to add b to get a plus 5 squared.
Oh, okay, yeah.
To complete the square. If it's minus this one, then this one would be minus. But you're adding again, half of it squared. So
Yes,
half
okay.
of 4, as long as the coefficient of x squared 1. If it wasn't 1, you need to factor out that one also.
Okay,
so
yeah.
just to refresh my memory, because I was about to say the same thing. If you had it negative, you would add it to the 5 if it was negative on the inside.
If negative 4x or positive 4x, you still add 2 squared and subtract 2 squared. But if it's negative, you get inside of the parentheses x minus 2 squared.
Yeah,
If
and
it
then you
was
would
positive, it would be x plus 2 squared.
yeah, and then you would add to the 4 instead of subtracting that situation, correct?
Mm-hmm. Yeah.
Pardon me.
Yeah.
May I ask what happened at stage 2 over here, number 2? It says y equals f of. It says right here that you got coordinate 1 and 2. Is this the vertex?
No. 2 says y equals f of x minus 2 plus 1, right?
Yes.
X minus 2 goes instead of x, you get x squared. Instead of x squared, you get x minus 2 squared plus 1. That should match with this. So this is the first step, and then the second step. So first you're shifting 2 units to the right, and then 1 unit up.
Yes. So, I mean, why do you have 2 sets of coordinates instead of just, well, two coordinate 2, 1?
Or you mean like 1, 2, and 2, 1 below that?
Yeah. Like,
That's
what's the point?
corresponding to those. 1, 2, this is 2, 1. different points. So one is this, one is that. And then 3, 2. 3 point on the graph. So I just plug it there to see if everything is right. This part is checking.
Oh, that part's checking. So wait,
Yeah,
which
it's
one
just
is
the last
which?
part is checking.
Which one is the vertex? Oh wait.
Vertex
oh,
is
it's
2, 1.
Oh, so HK is the vertex.
Correct.
Yes.
So if you have it completed, HK here
Yeah.
is your 2, 1.
All right. Thank you.
No problem. Any other question? Now, we definitely haven't finished 1.3, so we'll continue from here tomorrow. Now, the people that need to get like an add code or something, you just stay. The rest of the people can go. Well, I'll see you tomorrow.
See you tomorrow.
All right, bye.
See you.
Thank you, Professor. Have a nice day.
Bye. Have a nice
Thank you.
day.
Bye, guys.
Thank you.
Professor,
Good day.
Yeah.
Professor, for